Hi everybody, this is Mrs. Lehman. I couldn't be here today, so thank you to the substitute and thanks to you guys for behaving yourselves and being extra helpful today. I appreciate that. I expect great notes from the substitute. So right now you have a bell ringer, so I'm going to ask that this video get paused for probably, it shouldn't take you more than about 2-3 minutes. And after that amount of time is up, push resume and you can watch the answer. So go ahead and pause right now. All right, so you have a parallelogram here, and you have to find the area. So to find the area, you need to know the formula. Area equals base times height, right? 12 feet is our base, so we're going to plug in 12, and our height is 8. The reason that we're not using 10 is because 8 is perpendicular to the base. That is the height, which you are definitely looking for that 90-degree angle. So 12 times 8, that gives you 96, and the unit would be feet squared. So that means 96 1 foot by 1 foot squares would be needed to cover that parallelogram. The next question was something you learned in our last module. You have 6x equals 42. We have to solve for x. So to undo a multiplication problem, we have to divide each side by 6 in this case, whatever's with the variable. So in this case, it's a 6. So when you do that, that cancels everything else out there. You're going to get just x. So x equals 42 divided by 6, which is 7. So your answer for this bell ringer is 7. To check that, you would just plug it back in. So 6x equals 42. You would take 6, multiply it by 7. You would get 42, and 42 does equal 42, so we did that correctly. All right, so nice job with that if you got both of those correct. Today we're going to move on and learn about the area of right triangles. So you guys actually had this homework. We're going to go over this at the end of this video. That way if we're cramped for time, it won't interfere with the lesson. So we'll come back to that, okay? So, oh, by the way, on page 6, there is a calculator. You can feel free to use that at any point, all right? Anyway, moving on. This thing's really jittery. Lesson 2, the area of right triangles. So, there are 2 formulas that you need to know for area of a triangle. So we know area of a parallelogram is base times height. Well, a triangle is like a parallelogram cut in half. So we would say area equals base times height divided by 2. And with fractions, we're going to change this a little bit. If you divide something by 2, it is the same mathematically as multiplying it by 1/2. So we're going to say 1/2 base times height. And that will set you up for success when you're dealing with any numbers that are fractions. Okay, so again, you're going to use the one in blue on the left for whole numbers and decimals, and I would use the one in red on the right for anything involving fractions. All right, so, okay, so the nice thing about right triangles is we do need the height, and when we have right triangles, you'll notice this box in the corner here for number 1, right here, I'm kind of outlining it in red. That tells us that that is a 90-degree angle. So we don't need to worry about the height because with a right triangle, the height is a side. So we would use 8 feet and then 15 feet. This long side across from the right angle, that's called the hypotenuse. And we don't need to use the hypotenuse to find the area of a triangle. We just need the base and the height. All right, so first thing you would do is write area equals base times height divided by 2, because I don't see any fractions there. And then the reason we have base times height divided by 2 is if we were to look at this and kind of fill in this other side here, that would be a parallelogram. But we don't want the area of that whole thing. We want the area of just a triangle, obviously, so that's why that formula is divided by 2. Okay. So we're going to plug in. So area equals base, which is 15. The height is 8. Then we're going to take that number, we're going to divide it by 2. So this is going to require some math. So 15 times 8, go ahead and multiply that out. You're going to get 8 times 5, which is 40. Carry your 4. 8 times 1, which is 8, plus 4, which is 12. So we have area equals 120 divided by 2, one step at a time. 120 divided by 2, well, that is 60. And then we're going to look at our unit. We have feet, and it's area, so it's feet squared, or 60 square feet. All right, if you have any questions, you can always ask, and hopefully you can get some clarification there, but we're going to go through a few more examples, so just bear with me. Again, they're going to give you 3 sides, the length of 3 sides. Obviously, there are 3 sides here. You're only going to need 2 of them, just the base and the height. So really the tricky part is just, and it's not even tricky, it's just identifying which is the base and which is the height and which one you need to, out of the 3 sides you don't need. Like in this case, 10 1/3, that's what we call the hypotenuse. We don't need that. If we were finding the perimeter, we had to find the distance around the outside, we would need it, but we're just looking for the area. So we're going to take area equals, now you'll notice these are fractions, right? So we have 8 2/3 and 5 3/5. So we want 1/2 base times height. So we're going to plug in 1/2. Our base here is 8 2/3. Our height is 5 3/5. All right, so before we can do anything with this, we've got to get the fractions in the format we need, which is to convert those into improper fractions. So area equals 1/2. Now, to convert 8 2/3 to an improper fraction, we need to multiply 3 times 8, which is 24. We're going to add 2 to that, so that's 26 thirds. Then we're going to multiply 5 times 5, that's 25. 25 plus 3 is 28 over 5. All right. So now you have this, very lovely multiplication problem that you need to do. So one thing that really makes this easy is simplifying before you multiply. So you'll notice we have 1/2 here. And we talk about this concept. So you're going to look, this 2 here is an even number, right? So if you look across the top and you notice an even number, just chop one of those even numbers in half. So I'm going to divide the 26 in 2 and get 13. So then I'm going to get 13 thirds times 28 fifths. So, they made sure they gave you a nice crazy example to start with. So we're going to multiply 13 times 28. So set that up. 3 times 8 is 24. Carry your 2. 3 times 2 is 6. Plus 2 is 8. Put a 0 placeholder. 1 times 8 is 8. And 1 times 2 is 2. We've got to add those together. We're going to get 4. We're going to get 16. We're going to get 364. I should have given myself a little more room here. Good job, Mrs. Lehman. Oh, they're connected. All right, so 364. Don't erase your work, but I'm going to erase mine right here. Over 3 times 5 is 15. So you're going to get 364 over 15, which we need to put that back as a mixed number. So 15 doesn't go into 3, but it goes into 36 2 times. 15 times 2 is 30. We're going to get 6. We're going to bring down this 4. 15 goes into 60 4 times. And so 64 going 4 times, you get 60. You subtract, you get 4. So we're going to get 24, and then we're going to take this 4 as our numerator and put it over our original denominator of 15. So our answer is 24 4/15 meters squared, or square meters. All right. So again, it's always good to check reasonableness. So we have a number here, this 5 3/5. Let's say we say that's, close to 5. And then 8 2/3, we know that's close to 8, right? These are actually, I'd probably round up on those. So, 6 and 9. So 6 times 9 is 54, right? So 54 divided by 2 is, 27. So is our answer pretty close to 27? Yeah. And we rounded up, right? So our answer should be below that amount. So our answer of 24 and 4/15 does make sense. All right, so let's move on. That one was, you know, just a little trickier just because we're dealing with fractions, but not a big deal. All right, you'll notice we have a decimal and a decimal here, so I'm going to use the formula area equals base times height divided by 2, and then I'm going to plug in. All right, so base 21.4 times the height 32.7 divided by 2. So here we go, guys. I'm going to do this math down at the bottom so I have room. 21.4, 32.7. We're going to multiply these. Remember, you just put them down like there's no decimal. Regardless of where those decimal points are, you'd set it up the same. So 4 times 7 is 28. Carry your 2. 4 times 2 is 8. Plus 2 is 10. Carry your 1. 4 times 3 is 12. 12 plus 1 is 13. You're going to put a 0 placeholder. Now you're multiplying by 1. 1 times 7 is 7. 1 times 2 is 2. 1 times 3 is 3. All right, now we need to multiply with the 2. So we're going to put 2 placeholders because we're essentially multiplying by 200. 2 times 7 is 14. Carry your 1. 2 times 2 is 4. Plus 1 is 5. And 2 times 3 is 6. So we're going to add that up. I'm going to scroll this up because the smartboard doesn't like me to write there. All right, so let's see. 8 plus 0 is 8. Oh, I'm moving the board all around. Hold on a sec. Okay, 8 plus 0 is 8. 7 plus 0 is 7. 3 plus 2 is 5. 5 plus 4 is 9. We have 1 plus 3, which is 4. 4 plus 5, which is 9. And we have our 6. There you go. So now we got to figure out where to put that decimal. So we have one spot here, and we have one spot here. So you're going to start at the end and move it in 2 spots. All right, so our answer is 699 and 78 hundredths. So before that's not actually our answer, that's our product of the base and the height. We still have to divide by 2. So 699.78 divided by 2. So 699.78 divided by 2. 2 goes into 6 3 times. That gives you 6. Bring down your 9. 2 goes into 9 4 times. 2 times 4 is 8. I'm going too fast, so I'm slowing down. 2 times 4 is 8, so you subtract, you get 1. Bring down your 9. 2 goes into 19 9 times. That gives you 18. Subtract, you get 1. Don't forget to bring this decimal point up. Bring down your 7. 2 goes into 17 8 times. That gives you 16. Subtract, you get 1. Bring down your 8. 2 goes into 18 9 times. So 699 and 78 hundredths divided by 2 equals 349, and that looks like a decimal point. I'm going to erase that. 349 and 89 hundredths kilometers squared, or squared kilometers. All right, so let's again look to see that this makes sense. We have, you know, a number close to 20, a number close to 30. So if you take 20 times 30, you're going to get 600, right? And we're going to take 600, you got to divide that by 2. So 600 divided by 2 would be close to 300. And our answer, you know, we did a lot of rounding with that. So our answer is in the ballpark, so you know that makes sense. All right? I know there's a lot of multiplying and dividing going on, so again, you have to remember your rules for multiplying decimals and dividing decimals and multiplying fractions. All right? So we're going to keep doing some examples here. Let's move on to the next page. You have a problem set. We're going to try to get as many as we can done. So let's look at number 1. Okay, so we have a triangle. Now this one is kind of on its side weird, so we need to pay attention to the base and height. Again, you're looking for the perpendicular line. So right here, these are the 2 lines that form that right angle. So those are the lines that we're going to use the lengths of. So area equals base times height divided by 2. We have a base of 9.1 centimeters and a height. It doesn't really matter which one you say is the height and which one's the base. 31.2, and we're going to divide that by 2. So again, let's do some math here. 31.2 times 9.1. All right, we're going to multiply. 1 times 2 is 2. 1 times 1 is 1. 1 times 3 is 3. Put a 0 placeholder. Smartboard doesn't like me writing in that spot, so I'm going to move up a little bit. Okay, 9 times 2 is 18. Carry the 1. 9 times 1 is 9. Plus 1 is 10. Carry the 1. 9 times 3 is 27. 27 plus 1 is 28. We're going to add these two together. All right, now you'll notice we have 1, 2 spots past the decimal point, so we're going to move it in 1, 2. So we are going to get, right here, we're going to plug in 283 and 92 hundredths divided by 2. So we don't want to forget that next step of dividing by 2, right? So 283.92 divided by 2. 2 goes into 2 one time. That gives you 2. You subtract, you get 0. All right, we got to look at our next number here, 8. We're going to bring that down. 2 goes into 8 4 times. 2 times 4 is 8. Subtract, you get 0. Bring down your 3. All right, 2 goes into 3 one time. Gives you 2. You subtract, you get 1. You scroll this up. All right, I'm going to bring that decimal point right up. We're going to bring down this 9. 2 goes into 19 9 times. It gives you 18. Subtract, you get 1. All right, now we need to bring down the 2. 2 goes into 12 6 times. So 141 and 96 hundredths is what we would put next. 141 and 96 hundredths is our answer, and our units, we're going to look back up here. You'll see, I'm going to underline it in red, centimeters. So we're going to say centimeters squared, right? So 141 and 96 hundredths centimeters squared. All right, so if you look at that, 31 is pretty close to 30, 9 is pretty close to 10. So if you said 10 times 30, that'd give you 300. 300 divided by 2 would be 150. So our answer of 141.96 does make sense, all right? That's a reasonable answer. So it's going to take you a little bit of work and some workspace to show it all, but don't leave any of this out, guys. All right, we're going to work on number 3. Where's number 2? That's weird. Oh, it's down there. All right, anyway, I'm going to work on number 3 right up here with you guys. Just to save some space, I'm going to erase some of this, but don't do that on your paper. If you need more room, just grab another sheet of paper and staple it in. Do not erase your work. It is precious. All right, so, okay, we have all kinds of weird stuff going on in this one. All right, so in this next one, I am not sure why we have this random 5 centimeters going on. That's weird. So ignore that. Just cross that 5 centimeters off if that shows up in your module book. Does that show up in your module book? Let me look. If you look at yours on page 9, yeah, it's there. Cross out the 5 centimeters. That's weird. All right, so we need to figure out what the base and the height is. So area equals base times height divided by 2, but I see a fraction. I see a few fractions, so I'm actually going to use area equals 1/2 base times height. So area equals 1/2. Now the base. I'm looking at this clearly. You can see that that's 5. Now to write that as a fraction, I'm going to do 5 over 1, because that's how we write any whole number as a fraction. Now this right here, we need to turn 3 3/4 into an improper fraction here in a minute. So 3 3/4 is what our height is, because those are perpendicular as demonstrated by this box in the lower left corner. All right, so area equals 1/2 5 over 1 times, now 4 times 3 is 12, right? 12 plus 3 is 15, and then we want to over 4. So this is what we have so far. Now I'm going to multiply straight across, but before I do, I'm going to look to see if there's anything I can simplify. So I know if I have an even number on top, I can use the 2 on the bottom to cancel, you know, or to divide. I can divide the top and bottom by 2 there. But 5 and 15 are not even numbers, so that doesn't do me any good in this case. So I've got to multiply 5 times 15. Well, I know 5 times 2 is 30, so 4 times 15 would be 60, plus another 15 would be 75. So 5 times 15 is 75, and then 2 times 1 is 2, times 4 is 8. So we have 75 eighths. All right. Now again, you need to take that number, divide it to get a mixed number here. So 8 does not go into 7, but it goes into 75 9 times. That's going to give you 72. You're going to subtract and get 3 left over. I'm going to use that 3 as my numerator and use my original denominator of 8. So this equals 9 3/8 kilometers squared. All right, so there you go. Now again, let's take a look to see if this makes sense. You have a number pretty close to 4, right? 3 3/4 is close to 4. 4 times 5 is 20. 20 divided by 2 would be 10, right? We got an answer of 9 3/8, so that makes reasonable sense. So, all right, let's see. We are 22 minutes into this. You guys probably are at about 25, 30 minutes into class by now. So these next two are pretty easy. We've got 3 2/10 inches times 2.4 inches. So let's just set this up. See if we can get a few more done. Area equals base times height divided by 2. Actually, we'll get this one done and then go over your homework. So the base here, 2.4. So 2.4, the height is 3.2 divided by 2. All right, so we need to do some multiplication here. 2.4 times 3.2. All right, 2 times 4 is 8. 2 times 2 is 4. Put a 0 placeholder. This is where the smartboard gets weird. Right, so 3 times 4 is 12. 3 times 2 is 6, plus 1 is 7. We're going to add that up. We're going to get 7, 6, 8. We have 2 spots, so move this over 2 spots from the back. So we would get 7.68. And again, 3 times 2, we rounded those down, so we're going to get a number bigger than 6, and we got 7.68, which makes sense. And we're going to divide that by 2. So 7.68 divided by 2. So 2 goes into 7 3 times, that gives you 6. You subtract, you get 1. Bring up that decimal point, bring down your 6. 2 goes into 16 8 times, that gives you 16. You subtract, you get 0. Bring down this 8. 2 goes into 8 4 times. So our answer is 3.84, and then inches squared or squared inches. All right, so 3.84 inches squared would be your answer. Okay, at this point we're going to review your homework from the other day. So if you could flip back to pages 3 and 4, we are going to take a look at those. Let's see. All right, so, oops. Here we go for the problem set. So the first one says, draw and label the height of each parallelogram. So you would need to draw a line right here. And again, it's dotted because it is not an actual side. So this would be the height, and so would this over here. Right? If you could get that from top to bottom on the inside, that could also work there as well. All right, same on this one. You can go straight up from a vertex, all right, or straight down from a vertex, just as long as it accounts for the entire height. It could be any of those spots. All right, calculate the area of each parallelogram. Note that the figures are not drawn to scale. Obviously, you know, number 4, that is not 12.8 feet. Literally, it's just a scale drawing. So anyway, so in this number 3 example here, we have a base of 13, and this is the little box that indicates that it's forming a perpendicular line with this base, I'm sorry, with this height right there. So area equals base times height. Area equals 13 times 6. All right, so 13 times 6, you get 18, carry your 1. 6 times 1 is 6, plus 1 is 7. So you have an area for this one of 78 centimeters squared, or you could have written 78 square centimeters, either or. All right, over here you just had to deal with some decimals, so you're going to deal with 1.2 feet, and the height perpendicular to that is 12.8 feet. And again, you can recognize that by this box showing a 90-degree angle for those two lines. So area equals base times height. Area equals 1.2 times 12.8. So we just need to do some multiplying. So I'm going to put 12.8 on top, 1.2 on the bottom. 2 times 8 is 16. 2 times 2 is 4, plus 1 is 5. 2 times 1 is 2. Put a 0 placeholder. 1 times 8 is 8. 1 times 2 is 2, and 1 times 1 is 1. Add these numbers together. You're going to get 15. Let's see. 15, and move that in twice, 36 hundredths. So the area equals 15 and 36 hundredths feet squared, or square feet. All right, so check your paper, make sure you have those correctly done. Let's go on to the next page. On the next page, we already did 5 together, so we're looking at number 6. So number 6, you have 4 1/3. Now this right here, this 3 and 5, 6 is a trap. They want you to think you need to add that. In this case, you don't, because you want just the base and the height. So area equals base times height. Area equals 4 1/3 times the height of 3 1/2. All right, and then we need to convert these into improper fractions. So that's going to be 13 thirds times 7 halves. You can go ahead and multiply straight across. So 13 times 7, that's 91 over 6. So we don't want to leave it like that. So 91 over 6. 6 goes into 9 one time. That gives you 6. You subtract, you get 3. Bring down your 1. That goes in. 6 goes into 31 5 times. And that would give you 30. Subtract, you get 1. All right, so now you're going to take that remainder of 1, put it as a numerator, bring over your 6. So your answer here, the area is 15 and 1/6, and the unit was meters squared. All right, number 7 says Brittany and Sid were both asked to draw the height of a parallelogram. Their answers are below. Brittany drew the height on the inside, on the left-hand side here, and Sydney did the same thing, but on the right-hand side. So it says, are both Brittany and Sid correct? If not, who is correct? Explain your answer. So hopefully you said that they are both correct. Both Britt and Sid are correct. And the reason is the height All right, so I forgot where that was. I had a brief interruption there. It says both Britt and Sid are correct because the height on both answers is perpendicular to the base. All right. And the last question here, do the rectangle and parallelogram below have the same area? Explain why or why not. So, so this is a parallelogram. Here's the base. Here's the height. This has a perpendicular side. So in this case, we can use a side. So area equals base times height. Area equals 15 times 8. So if you take 15 times 8, you get 40. 8 times 1 is 8, plus 4 is 12, so you get 120. So 120 feet squared for this guy on the left. And over here, you would have the same numbers plugged in because the height here is 8 and the base is 15, so those would multiply to give you the same exact area. So they both have the same base and height. So you'd say both the rectangle and parallelogram have the same base and height dimensions. So, there you go. All right, guys, your homework tonight is a worksheet called, let me grab it here, The Biggest Sleepyhead. And you guys have some pretty easy examples there. I want you to write the formula for every one. Area equals base times height divided by 2 because they're all triangles. And then I want you to plug in and calculate and then label your answer with whatever unit they give you squared. Okay? So you'll be passing that in tomorrow. Thank you guys for being good. Have a great day. You can use whatever time is left, probably not much by now, to continue or to work on your homework. And thank you to the substitute and have a great day. I'll see you guys tomorrow. Bye.